All right, welcome. So again, we're talking about arc length and circumference. And the main thing we talked about, circumference, is 2 pi r, or diameter times pi. And that's the whole way around the circle. And so what we talked about, though, was that if I am only going, so like I've got, for example, in this example, this would be if the radius is 5, what our circumference would be 10 pi, right? 10 pi whatevers. Now, though, if I'm only at like 180 degrees, I would only be at half of 10 pi, or 5 pi. Or if I was at 90 degrees, I would only be at 1/4, or 2.5 pi. Or if I was at, for example, 60 degrees, right, 60 degrees, about there, I would be at, for example, 1/6 of the circumference, right? 1/6 of the circumference, or 1/6 of 2 pi r. And since the radius is 5, 1/6 of 10 pi, right? And so I would get, what, 10 pi over 6 as my answer, 10 pi over 6 as this length. Oops. Okay, so the whole point is just asking yourself, okay, what fraction of 2 pi r do we have? And that will be the length, right? Remember, the whole length is always 2 pi r, or diameter times pi, and we just say, hey, what fraction? Okay, so we're going to try to practice some of these problems, so make sure you have your paper. Let's go ahead and take a look. All right, so we're on this page, page 13 here. Make sure we're on page 13. And so we're just talking like what we said here. If I'm only going part of the way across, like if I was 180 degrees, I would be half circumference. Let's say I'm only going 90 degrees, so if it's the same tire, 90 degrees would only be like from here to here, so that would only be like this distance here. Well, that is only, right, that's only 1/4 of a circumference, right? And so how do I get this fraction if it's not so easy? The key is to set up this here, like 180 out of 360, that's half, right? That's why it's half a circumference. Or if it's a quarter, where does that quarter come from? You just basically set up a little fraction saying 90 out of 360 of the circumference, right? So if you think about it, 90 out of 360, that's just 1/4. So you're telling yourself, oh, that's right, I'm only going 1/4 of the circumference. I'm only going 1/4 of 2 pi r. Right, and in this problem it was 26 pi, right, because the radius was 13 inches. So we get 1/4 of 2 pi r, or 26 pi. Okay, so our total distance is 26 pi divided by 4. 26 pi divided by 4 inches. So 26 divided by 4, I can't do that, but I can divide 26 pi over 4. You can write it like that. You can divide numerator and denominator by 2. We get 13 pi over 2 inches. By the way, I think if you're in period 3, I forgot to do a little conversion here. So in case you were confused by this, I realized I'd forgotten to do something. So make sure you don't do this. When you have something in inches and you're converting it in your feet over here, what I forgot to do in class for period 3 is this was in inches. I'm sorry, this was in feet, excuse me. And this was in inches. So we had this thing we had to convert, and I forgot to do that on our paper here. So 500 feet divided by inches, that's not really going to work. So what we want to do is we want to convert this feet to inches. Remember, 1 foot equals 12 inches. Right? 1 foot equals 12 inches. So to turn this into inches, you want to multiply by 12. Right? 5 times 12 is 60. So this would become 6,000. So not 500, 6,000 inches, right? 500 times 12 gives you 6,000. Okay, so this is the 73.5. This is the actual answer. I just forgot to multiply it by 12. So make sure your units are matching up, inches and inches, to get that ratio. Okay, so sorry about that little diversion, but this is what we're doing for arc length. Always ask yourself, what fraction, how much out of 360 are you turning? Let's go ahead and practice. Okay, so arc length. On the other page here, again, an arc length is really just a fraction, right? What fraction of the circumference are we going? It should have units like feet, inches, right? What fraction of a full rotation, what fraction of diameter times pi or 2 pi r have you traveled? Okay, so for example, if I rotate 30 degrees, if I start from here, is something kind of like this much, just a little amount, right? What fraction is that? Again, what's the trick? You just take it out of 360. You say 30 degrees out of 360 degrees. Degrees out of degrees will just cancel out, so we're left with 30 out of 360. Right? 30 out of 360, I divide that by 10. I get 3 out of 36, 10 over 10, excuse me. And I divide by 3 over 3, and I get 1/12. Okay, so just practicing getting this fraction, you just take it out of 360. That's 1/12 of the circle, right? 12 of these fit inside. What about 120 degrees? 120 degrees would be more like, well, here's 90, so like a little bit more, so like about there. What fraction of the whole circle is that? Again, we just take it out of 360. You take 120 degrees out of 360 degrees. Degree over degree becomes just 1. So we get 120 over 360, divide by 10 over 10, and I get 12 out of 36. I can divide by 12 over 12, and I get 1/3. Right? So 120 degrees is 1/3 of the way across. Right? 3 of these fit into the full circle. So just practice being able to find that. Okay, let's go ahead and try. Let's do A and B together, and then try C on your own. So again, arc length. Find the length of the red arc, and I mean this one right here. Okay, so we think to ourselves, okay, for a full rotation, the length would be, right, for the full rotation, the length would be 2 pi r, right, the circumference. And we just ask ourselves, what fraction of that, how much out of 360 degrees have we rotated? Okay, so for this one right here, I say to myself, okay, my arc length, so we say arc length of arc AB. Remember, they got that rainbow symbol. Arc length of AB equals, and then I'll put a little parenthesis here. Okay, 2 parentheses really. And this is going to be the fraction, and this is going to be the circumference. Right? This is going to be the circumference. To say what fraction of the circumference. And remember, how do you find this fraction? You just say, well, how much is 60 degrees out of 360? So you go ahead and just put 60 degrees out of 360 degrees. Right? The arc length is just what fraction of the whole thing. We can simplify this, degree over degree, okay, 10 divided by 10, so I get 6 out of 36. 6 out of 36, and 6 out of 36 reduces to 1/6. And that kind of makes sense if you look at that. Yeah, like there's about 6 of these in the whole circle, so I'm 1/6 of the way of the whole circumference. Right? How do I find the circumference? Again, I can use 2 pi r or diameter times pi. I'm going to use 2 pi r. And so my radius is 8 centimeters. So it's 1/6 of 2 pi times 8. Okay. So it's 1/6 of 16 pi. Okay, let's make sure, I guess I could put centimeters here, but I'll just do it on the next line. You can combine this, remember, because this is like 16 pi over 1, so it's really just like 16 pi over 6. 16 pi over 6. Always see if you can simplify just a little bit. Since I can divide the numerator and denominator by 2, I'm going to do that. 2 over 2, that's just 1, so I'm not changing the number. I get 8 pi over 3 centimeters. All right, make sure you label those units. 8 pi over 3 centimeters. And on a calculator, if I check that, 8 pi divided by 3. 8 pi divided by 3, about 8.38. About 8.38 centimeters. Okay. Now, let's look at part B. Look at this. It's the exact same 60 degrees, and yet the circle is bigger. This is like we talked about with that little GeoGebra thing. Even though it's the same measure, remember from central angles, this is 60 degrees, this is 60 degrees, right? 60 degrees, 60, it's a central angle, right? So just notice how the measure of an arc in degrees, I'm just going to write that, can be the same, right, for different sized circles. So 60, 60, 60, 60, but the arc length, right, how long it is going to be different, right? Because you can look at this, you can see, oh yeah, this is clearly longer than this because the circle itself is bigger. So the measure is the same, but the arc length is different. Let's calculate how much different. So part B, so the arc length of EF, arc EF equals what fraction Well, we already did that. What is 60 over 360? That's just 1/6. Right? 1/6 of the way across of this bigger circle. Right? We capture that by saying 1/6 of the circumference. Right? 1/6 of the circumference. So 1/6 of 2 pi r. So that's 1/6 of 2 pi times, not 8 this time, 11. There's our bigger number, 2 pi r. So 1/6 of 22 pi. Right, 1/6 of 22 pi. I can put this over 1, so I could see, oh yeah, that's 22 pi, 22 pi over 6. Okay, I can reduce that by dividing by, let's see, 3, no, 6, no, 2 over 2. And I get 11 pi over 3 centimeters. Okay, so it's clearly bigger. How much bigger? Let's take a look. 11 pi over 3. Well, 11.52 approximately. 11.52. Okay, so we see here again, yes, the measure, because there were central angles, 60-60, 60-60 degrees, that's the same, but the length, of course, was different because this is a bigger circle. So 1/6 of a bigger circle is a longer length. All right, go ahead and pause the video, try letter C, and then we'll come back and talk about it. All right, if you're doing it, if you haven't done it yet, try it on your own first before we talk about the answer. Try it on your own. If you're stuck where to start, arc length equals, put some parentheses, think what fraction of the whole circumference, right? What fraction of the whole circumference is 120 degrees? All right, I'm going to show the answer in a few seconds. Try it on your own. Okay, hopefully you did it on your own. Let's take a look here. So I say 120 out of 360, right? What fraction is 120 of 360? Again, we already did that. 120 out of 360 is just 1/3. 1/3. So I'm going 1/3 of the way of the whole circumference. 1/3 of 2 pi r. Right? 1/3 of 2 pi r. So that's 1/3 of 2 times pi times, in this problem, it's also 11. So it looks like it's actually the same or a congruent circle as the previous one. So this time I have got 1/3 of 22 pi. Same thing, just a bigger portion of that. Okay, and again, I can put this over 1, 22 pi over 3 centimeters, and I can't divide because this is a prime number. I can't divide by top and bottom anything else, so this is it, 22 pi over 3, 22 pi over 3, 23.04, 23.04. Now if you look carefully though, I should probably box this one up as well. Look, this is exactly double this one. It's exactly double this one. Why? Because look, it was congruent circles, 11 and 11, and 120 is double this, so instead of 1/6, it was 1/3. So of course this length is double this length. So just be on the lookout for those kind of things. All right, I'll try a couple more problems here. So let's just put to formal notation what we've been talking about here. So from arc length, we ask ourselves, okay, what is this length of this guy, the actual length, not the degree measure? Right? So we say to ourselves, all right, I can look at it two different ways. So right here, I can look at it like a proportion. Right? You can make it like a proportion. You could say, okay, what is the fraction that this is of the entire circumference, right? Like, okay, this is, I don't know, 10 feet, and this is 30 feet, so that would be the whole fraction. Would be the same ratio, right? Would be the same ratio as the degree measure is out of 360. Okay, that's one way to look at it. You can make a proportion, or this is the one we've been doing. If you just multiply both sides by 2 pi r, right? You multiply this by 2 pi r, multiply this by 2 pi r. 2 pi r goes away over here, and it comes out over here. This is what we've been using. We've just been saying the arc length is just what fraction out of 360 times 2 pi r, right? What fraction out of the whole thing do we have here? So pick whichever one. This kind of just gives you the arc length. This one makes it like a proportion, right? So this length out of 2 pi r is equal to the same ratio as the degree measure is out of 360. Feel free to use whichever one's easier. Let's do A and then B, and we'll save 11. So let's find the circumference. So this is a little bit weirder. Again, you have something that's not what we normally did, we actually have the arc length here. See, 4.19. We know the arc length. And we know this is 40 degrees. We do not know the circumference, though. We don't know the radius. So let's think about this. Let's use this one, the one we're familiar with. Okay, so the arc length of, what is this, xy equals, okay, just like normal, and it's going to be what fraction out of the whole circumference, right? Here's the fraction. I can figure that out right now. 40 degrees out of 360. Right, 40 out of 360. Now here's the thing. Normally we plugged in the circumference. Again, this time though it's kind of backwards. We don't know the circumference, and we know the arc length, right? The arc length is 4.19 inches. So I'm going to plug in 4.19 right there. And 40 out of 360, I could divide by degree, 10 over 10. That's 4 out of 36. 4 out of 36. Let me think that. 4 out of 36. If I divide by 4 over 4, that gives me 1 out of 9. So this is actually 1/9. 1/9 of the circumference. Okay? So to solve for the circumference, all I have to do then is just take this 1/9. How do I clear 1/9? Well, it's just do the inverse of dividing by 9. I multiply both sides by 9. I multiply both sides by 9. So 9 over 9 becomes 1. And I get my circumference is 4.19 times 9. And that is approximately 37 point, 9 times 4.19, 37.71 inches. Okay. So try a problem, try letter B, again pause the video and come back after a couple minutes. How do you find this arc length, RS, RS, the minor arc, what's the minor arc? Sorry, not the arc length, excuse me, the measure. So I want you to find the degree measure. The degree measure. So you can either use this one, like we've been doing, you can use the proportion, set up and plug in what you know, and solve. You know the arc length. What is the degree measure? Like, is it, I don't know, like, it looks like it's like 100 and something degrees, like 150, 160, 170 degrees, 130 degrees, what is it? Okay, go ahead, try. Okay, we're back. So this time I'm just going to try, throw it up a little bit. I'm going to try using this one, the proportion. You could, of course, do this one. That's fine. You can set up and solve. But let's plug in the arc length. Do I know the length of this guy? Yes, it is 44. 44 meters over 2 pi r. 2 pi r. So in other words, this is this length out of the whole length. What is the whole length? What is the circumference? I can get that fairly easily. 2 pi times the radius, which is also given. That's 15.28. So I'm doing this one over here. So I'm saying this fraction is the same as this fraction. So what is the measure of this arc? Well, that's the thing I don't know. How many degrees? I'm trying to figure that out. So I'm going to leave that as the measure of RS. Right? This is what I'm trying to find out of the whole measure in degrees, which is 360. Again, you could have used this one. I'm doing this one. You're just saying this over this, right? This length to the whole length, which I know both of those numbers, is the same as this degree, which I don't know, to the whole degree, which we know is always 360 for a circle, right? So this fraction equals this fraction. It's just a proportion. Okay, just to help us understand that a little bit more, I'm going to actually type this up. 44, now here's what you want to be careful about. You want to do divided by, and you want to put parentheses around the whole thing, because if you just say divided by 2 pi times 15.28, look at this. This is wrong because you're going to be dividing by 2 and then multiplying by the rest. It's like you put these up here. You don't want to do that, so I'm going to clear that. You want to do 44 divided by parentheses 2 times pi times 15.28. All right, so put it all in parentheses. Just go back here. 44 divided by parentheses 2. You don't need this one. 2 times pi times 15.28 parentheses. So 0.458, so 0.46 we'll say, 0.46. So what does that number represent? Oh, this red pen is dying. 0.46, again, is just like the fraction, the percentage of the way around. This is about 46% away around. If I use that proportion, so I say to myself, what is 46% of 30 or 360 degrees, right? If we find that, then we'll find our answer here. So shouldn't have left that unkept. Okay, I'm switching pens. So basically, I just multiply by 360. Right, we're just saying what fraction, or 46% of 360 is going to be how many degrees. So I'm just going to keep this in my calculator, keep it more accurate. We'll multiply by 360 degrees, and I get 360 at 164.99. 164.99. So measure of arc RS is approximately 164.99 degrees. So about 165 degrees, right? So we can see this right here is about 165 degrees, right? This is about 165 degrees because central angles are the same measure, not the same length. Okay, actually I decided let's do 11, a little bit more challenging to finish this up here. How do I do it when I'm combining pieces? So I've got a track here, and you all know that when you're running on the inside and the outside track, we have more to run out here and less to run out here. So let's say we are running on the inside path. Let's call this the red path here. Okay, what is this total length? Right, what is this total length? And so what we notice here is that part of this is just a straightaway, right? What is this total distance? Part of this is just the straightaway. So I've got 84.39 here. I've got 84.39 here. Here I've got part of a circle, and here I've got part of a circle. Right? Think to yourself, what fraction of the whole circle do I have here and here? There's actually two ways to do it. Why don't you pause the video and try this one yourself. Okay, so coming back here, how do I find this? Well, one way is to actually use this concept of arc length. If you take a look here, this measure, right, this degree is 180 degrees, right, because this central angle is 180 degrees. So if I say to myself, hey, what fraction of the whole circle is that? Again, we can just say to ourselves, arc length, I don't have a name for it. We'll say arc length is what fraction of the whole circumference, right? What fraction? It's 180 out of 360, right? And you can just do this in your head, but 180 out of 360 is, again, just 1/2. 1/2 of the whole thing. Now, what is the circumference? Again, we can use that formula, 2 pi r. 2 pi times, what is the radius? It's kind of covered up here, but it was 36.8 meters. Okay. Now, we can simplify this before we get going. Half of 2, 1/2 times 2, that's just 1. So I'm left with 36.8 pi. 36.8 pi meters. That's just this guy. Okay. Now, if I have this guy over here as well, so I know that this is 36.8 pi, and this is 36.8 pi. I could round it to a decimal, but I'm just going to leave it as pi, right? Because they're both just congruent to each other. So my final distance, my distance would be 84.39 times 2 plus 36.8 pi times 2. This is all in meters. And then I'm just going to punch that in my calculator, right? 2 of these 84.39s. So that is 84.39 times 2. So that's 168.78 meters plus 2 times 36.8. And you could put times or you could just put pi. You can do it. And that's about 231.22. I guess it's approximate now. So I just add these two numbers up. I'm going to leave this in my calculator. I'm going to add 168.78. And I get 400, which if you run track, you know that that is the correct distance around the track, right? 400 meters is the correct distance around the track. Now I said there was two ways to do this. If you were looking closely, you would notice that these two pieces are really just one whole, right? These two pieces really just make one whole if you just kind of combine this part and this part. So we actually didn't have to take half of this. All you'd have to do is just find the circumference, right? 2 pi times r, which was 36.8, and you would get this number, right? You would get this 231.22. So if you just put these together in your mind as one big circle, you didn't have to kind of break it in half and then multiply it by 2 again. But either way, it gets you the correct answer. Okay, so I'm going to transition us now. We talked about arc length and circumference. I want us to take out our notes for the next one, which is going to be page 15. Page 15. So let's go ahead and label this as page 15. Okay. So, as an intro to chapter 11.5, click on this area of circle formula link here. So now we're transitioning. We were talking about circumference, right? We were talking about this black part, right? The length of the part on the outside, and then also a fraction, the arc length. Now, what is the area formula, the inside part? You know, we know the circumference is 2 pi r, and area, hopefully you remember the formula for that, pi r squared. But where does pi r squared come from? I just thought this is a really cool GeoGebra that I did not make. These people made it. Where does it come from? So basically what we can do is, again, kind of unwrap the circumference like that. You can all do that together. I unwrap the circumference, kind of lay it out. Click here and see, oh yeah, 2 pi r. This length here is 2 pi r. Now, to find the area, that's the inside part, I can dissect it into 6 slices, and then move this rearranged down here. You see, okay, it kind of goes like that, and then it folds back on itself. So what you can see here is this kind of looks like a lumpy parallelogram, kind of, right? Now, this is a concept again from calculus, but the idea is, okay, that kind of looks like it. What if I go to this red bar and increase the parts to like 22 or something? Rearrange it again, so instead of being a pretty lumpy parallelogram, it looks pretty close to a parallelogram. Okay? And if I go and I rearrange the parts to be like a super high number, like, I don't know, 200, and I rearrange that, now it really looks like a parallelogram. Okay? So this idea comes from calculus, the idea of sending things to infinity. When it becomes an infinite number of slices, it actually becomes an exact parallelogram. So in other words, this came from the circle. If I find the area of this parallelogram, I have found the area of my circle. So think to yourself, if this whole thing is the circumference, right, 2 pi r, what is just half of this? Right? Isn't that pi r? And what is the height of our parallelogram, right? Base times height. Base pi r times height r. Pi r times r. This area is pi r squared, which, as we remind ourselves, is the exact area of the rectangle. So pi r squared.